In a cancer drug trial, the doctors found that the number of cancer cells decreases to 1/3 in a week to its current level. So in every week, the cancer cell decreases to 1/3 to its current level. If the number of cancer cells present in the third week is this, then find what was the number of cells present at the beginning of the trial. Okay. Let us assume the number of cancer cells at the beginning is N0. Then the number of cells after 1 week. The cancer cell decreases 1/3 in a week to its current level. So initially it was N0. So after 1 week it will decreases to 1/3 to its current level. So 1/3 of its current level is N0. So it will be N0 division 3. Now this is after 1 week. So the number of cells after 2 weeks will be, so this was at the end of first week. In the week time, that is in the second week, it will reduce to 1/3 of this level. So 1/3 of this level, N0 division 3, which is N0 division 3 square. So after 2 weeks it is N0 division 3 square. Number of cells after 3 weeks. At the end of 2 weeks is this, and at the third week the number of cell will reduce to 1/3. So it will be 1/3 of this value, which is N0 division 3 square, which is 3 times 3 square is 3 cube. So it will be N0 division 3 cube. Now we are told that the cancer cell present in third week is this. So that means N0 division 3 cube is this. From there we need to find the number of cells present at the beginning. That is, from there we need to find the value of N0. So question A, N0 division 3 cube is, this value is this numbers of cells, 2.7 times 10 to the power 5. 2.7 times 10 to the power 5. So from here we can find that N0 equals, this 3 to the power 3 will be multiplied here. So 3 to the power 3 times 2.7 times 10 to the power 5. So if we calculate it, we will get 3 to the power 3 means 27 times 2.7, it will give us 72.9 times 10 to the power 5. Now if we take this decimal point 1 left and keep it in the standard form, then it will be 7.29 times 10 to the power 5 plus 1, that is 6. So the initial number of cell was 7.29 into 10 to the power 6. Okay. Now question B, what would be the number of cells after 5th week? So if we see the pattern, number of cells after 1 week is N0 to division 3 to the power 1. After 2 weeks, N0 division 3 to the power 2. After 3 weeks, it is N0 division 3 to the 3. So the number of cells after 5 weeks will be N0 division 3 to the power 5, where N0 is this, where N0 is 7.29, N0 value is 7.29 times 10 to the power 6 division this 3 to the power 5. So now if we calculate it, if we calculate this part, we will get 0.01 times 10 to the power 6. Now if we take this decimal point 2 digit right, it will be 1.0, and then this power will reduce by 2, so it will be 10 to the power 4. So the number of cells after 5th week is 1.0 10 to the power 4. Now question C. Express the relation between the number of cells present and the number of weeks the drug used by an equation. So we need to find a general equation. So here we can see after 1 week the number of cells is n0 by 3 to the power 1. After 2 weeks it is n0 by 3 to the power 2. After 3 weeks it is n0 to the 3 to the 3. So in general the number of cells after t weeks if we denote it by nt will be n0 division 3 to the power t. So this is the exponential relation for number of cells after t weeks. Question D. Use this equation to find the number of cells after 6 weeks. So that means this is after t weeks. If t equals 6, so when the time is 6 weeks instead of t weeks, 6 weeks, so t is 6, then the number of cell nt will be n0 by 3 to the power 6. Now n0 we know, which is 7.29 times 10 to the power 6 and division 3 to the power 6. Okay, we did a little bit of mistake here in calculation. This calculation 7.29 division 3 to the power 5 will give us actually 0.03 and now if we take this, so it will be 3.0 to the power 10 to the power 4. And actually this calculation, if we calculate 7.29 to the power 3 division 3 to the power 6, we will get 0.01. So I just mixed up the calculation a little bit. So now 0.01, if we take the decimal point 2 digit right, we will get 1.0 times the power will reduce by 2, it will be 10 to the power 4. So after 6 weeks the number of cells will be 1.0 times 10 to the power 4. So basically I mixed up these two calculations. Okay, now finally E. Use the equation and find the number of weeks it will take to drop the number of cancer cell below 1000. So the number of cancer cell nt is n0 division 3 to the power t, and where n0 is 7.29 times 10 to the power 6 3 to the power t. So now we need to find the number of weeks so that this number of cancer cell is below 1000. So for E, the number of cancer cells 7.29 times 10 to the power 6 division 3 to the power t, that is the number of cancer cell after t weeks. It has to be less than 1000. So from here we will be calculating this t. Okay, now if we do this 7.29 times 10 to the power 6 division, if we bring this 1000 this side, it will be divided, then 3 to the power t. So it will, 3 to the 2 will be on that side. Okay, now 10 to the power 1000 means 10 to the power 3. So 10 to the power 3 and 10 to the power 6 will give us 10 to the power 3. So we will be getting 7.29 times 10 to the power 3 less than 3 to the power t. So now to calculate this t, we need to take logarithm. So logarithm of 10 7.29 times 10 to the power 3 is less than logarithm of 10 3 to the power t. So this t will come in front. So we will get, so this t will come here. So we will be getting t. So t times logarithm of 10(3) is greater than logarithm of 10 base 7.29 into 10 to the power 3. 7.29 times 10 to the power 3. So we will be getting t is greater than, if we take this one on the right hand side, it will be log 10 7.29 times 10 to the power 3 division this log 10 3. So if we calculate this using calculator, we will get approximately 8.1. So t must be greater than 8.1 weeks. So after 8.1 weeks, the number of cells will go below 1000.